Welcome to BKW Physics. I'm Mr. McConley. Today we're going to do a demonstration which has to specifically focus on Newton's second law. Newton's second law, to review, is F equals ma. Net force is mass times acceleration. So here's the situation. You're going to have to kind of make some conclusions here. I have tied a string to the pedal. And this string is going to be pulled on this way. I'm going to pull back on the string. And the question is, if I pull back on the string, which way will this bicycle move? So let's just hear some ideas here. Volunteer some thoughts.
Forward.
There's a forward. Reason?
That's the way you pedal to make it go forward.
Well, this person says, you pedal like this to make the bike go forward. Therefore, if you pull back on the string, that's like pedaling like this, the bike should go forward. Okay, fair enough. Anyone else? Other thoughts?
Maybe it might go nowhere.
Might go nowhere. Why?
If you're putting a certain amount of force pulling, when you're pulling backwards, the amount of force you're going to have going forward might be equal to that. So it's like a point.
It's a good thought. So you are sort of agreeing with the first student who said, you pedal this way, it makes bikes go forward. But you're adding the idea that, yeah, but you are pulling backward, and the backward pull might cancel the forward mechanism of the bike, and it might go nowhere. Okay? What if I tell you I will pull hard enough so that it will go somewhere?
Okay.
Does it change your opinion?
Yeah.
Which way is it going to go now?
Wait, if you pull it, wait.
I'm going to pull hard enough that something's going to happen. It's not going to sit there.
Well, that makes no sense.
It goes backwards. It's going to go backwards. You're a tricky guy.
Backwards?
It's tricky.
Because I'm a tricky guy.
It's a tricky
Do you have more scientific reasoning here?
Yeah.
You're thinking something?
It'll go forwards quickly, but then backwards.
Because it can't go
Forward quickly, then backwards?
If you're pulling backwards, it can't go forward even more. It can only go like a half circle.
So because of the way pedals move,
Yeah.
this pedal will rotate to here,
Yeah.
and then all bets are off.
Yeah.
Okay.
Go
I'm
backwards.
saying backwards.
Backwards, you say?
Backwards.
Okay. My assistant says backwards. So, you ready to see what happens? I'll do it a variety of times. I'll pull various strengths, and all that I ask you to do is keep the wheel straight so that when I pull it actually goes forward or backward straight and it doesn't curve, okay? Alright, so this time I'll pull very gently, just 2 fingers. I'm probably off camera, but I'll just pull with 2 fingers real gently, just enough to creep it right on back. Okay? So that creeps right on back. Are you in any way affecting this?
No,
What are you doing?
I'm holding it and keeping it
Simply
balanced.
balancing it. He's not affecting it. I didn't pay him beforehand.
This could be like a Ouija board now.
Okay? Could be, but I doubt it.
That explains it.
Now that changes everything. So this time I'm going to give it a pretty stout yank. Okay? You ready?
Yep.
Boom. And catch it there. It's getting out of control. Not bad.
I'm just trying to keep it balanced.
Medium pull. Well, actually, it's in the wrong position. Medium pull. Wow, it just keeps going backwards. It's ridiculous. But it doesn't make a difference where I put the pedal.
Oh, it's because the wheel's moving. So it's going
Like if I put the pedal here, what happens?
It moves backwards.
Backwards. If I put the pedal here, backwards. If I put the pedal here, backwards. It makes no difference where I put the pedal. The thing is always going backwards. This is Newton's second law. Newton's second law says, when you apply a force, the net force, it will accelerate in the direction of the net force. Period. The thing will go back because it has to go back according to Newton's second law. Well, then let's just take it one step further here. One step further. Are you claiming then, if I were to sit on this bike, or I were to put my foot on this pedal, and then I were to take my foot and pull my foot backwards, you know what I mean? Like your foot's on the pedal and you go like, and you try to pull your foot back, like if you put your foot in the clip here so it doesn't slide out, and you pull your foot back, am I claiming that the bike will move backwards?
No.
Let's try it. I put my foot on the pedal, and I pull backwards with my foot. The bike will move backwards. Did you know you could do that with a bike?
What?
This is not a magic bike, by the way. It's a normal bike.
I was assuming that both feet were off the ground.
If you put your other foot over here, this foot will probably cancel out. So if I had a foot here and a foot here, and I try to pull back and like fighting myself, but if I put one foot on one pedal right here, and I pull back with this one foot on the one pedal, it might go back. Truthfully, it does. I'm not doing any magic here. This is Newton's second law. Net force is mass times acceleration. The acceleration will be in the direction of the net force. For today, physics.